And hello, this is 1.4 worksheet. If you want to try them all on your own, here's some hints down here for the different problems, and you can also come back to those hints later on if you're viewing it and you're going, no, I still don't know all of it. I'm typically going to, again, show the odds in class so that you have some ones that you can follow verbatim and some ones you can try. Remember to always try every problem. When you're submitting these, honestly, I think the best thing to do is to work it out by hand and then take pictures of it and then put those images into one document, either a Word document or a Google document, and then go file, download as PDF. Then you have one small file that you're uploading. It reduces the chance of glitches and any other problems. So I do recommend you follow that process. So what was it that I have to do? Givens, unknowns, equation, substitute, and solve. So an Cessna airplane has a takeoff speed of 28 meters per second, 63 miles per hour. So that is my velocity. I don't know if it's initial or final yet. I got to keep reading. Determine the minimum length of runway, which will be required for the plane to take off. Determine the minimum length. That is the distance that we're going to be finding of the runway for the plane to take off. Okay, so that takeoff speed in this case is going to be the final because I am concerned about the plane taxiing and then taking off. So this 28 meters per second is at the end. And yes, I'm not an artist, as you can tell, but sometimes just sketching that out gives you just an idea of what's going on. And we have an average of acceleration of 1.9 meters per second squared. So I'm going to, again, I have my givens. Okay, I have my unknown. I have it labeled just like this. This is all that you have to do. You might want to add a question mark here to help you out, but you're not necessarily going to use the formula that says D equals because you might not have all that information. Okay, and so in this case, I am going to be using V final squared equals V initial squared plus 2AD. All right. So this one was the same setup basically as what we had on the last recording. So I wasn't going to go through and tell you how we found that equation, but I will take time to do that on the later ones. Velocity final can now be substituted in 28 meters per second. You're in physics now, keep the units in there. Don't just write 28. Velocity initial. What do we need? Oh, what's happening right here? Velocity initial is what? It's at 0. So I can just put a 0 in here. Plus 2 times the acceleration. The acceleration is 1.9. And what am I left with? Distance. So when I solve this problem, then I would have the distance. So when you're setting it up here to show the work, you would say 28 meters per second squared equals 0 plus 2 times 1.9 times distance. Okay, and then you could just then write the answer after that. Your distance and what you got. I got 206.3 meters. And then I'm going to box my answer there so it's easy to find. So that's kind of the setup that you're going to do each time. Okay. So number 3, Emma Russian can travel from Milwaukee Avenue to school entrance gate at a constant speed, constant. Okay, and you can still use the V, but that's going to be your V average when the lights are green and there's no traffic On Wednesday, Ema stopped by a red light at Landwire Road. She decelerates at -3.95 meters per second square, then waits for 45 seconds. So that I'm going to say time, and then I'm going to use subscripts, time stopped. Hey, you can use whatever you want for there, but just use something to indicate that is when they're stopped, not when they're decelerating and not when they're accelerating again. Okay, so I'm going to say acceleration 1 and acceleration 2 to help that. Determine the total time required to decelerate, stop, and accelerate again. Okay, so the time is going to include, sorry, I put a lowercase t there, time of decel plus time of stopped plus time of accelerate. The time of decel, we don't know. Which is the only one I do know? Time of stop. So I'm just going to fit that in right now, 45 seconds. Then I'm going to come back. All right, so what do I know? Let's draw a picture. Okay, normally she goes 22.5 meters per second all the way from point A to point B. But today, she's going 22.5 for a certain amount of time, and then she is decelerating for a certain amount of time, and she stopped for a certain amount of time, and she's accelerating for a certain amount of time, and then she's back to 22.5. So what do I know? So when I'm worried about this one here, that's my decel. I don't know the time that I'm decelerating. That's what I'm trying to find. So time, we don't know what that is. What do I know? I know my initial velocity because it's going 22.5 until we get there. What else do I know? I know my acceleration for right there is -3.95. So what am I also possibly needing? Velocity final. What would be my velocity final? Oh, I'm stopped here. So my velocity to be 0. So I know velocity initial, I know velocity final, and I know acceleration. So when I look at that first thing, I have velocity average is equal to distance over time. Okay, but my velocity isn't a constant, so I'm not going to be able to use that. I have velocity final equals velocity initial plus AT. And what do I know there? I know my velocity final, I know my velocity initial, I know my A. Oh, I can stop right now. T is the only thing left. So I would use that information to solve for T, and that is going to be which T? TD. And TA, what's happening in this case? Okay, that's this little segment here. I know my acceleration, 4.91 meters per second squared. What else do I know? I'm stopped over here. So in this case, my velocity initial equals 0. And what's the 22.5? That is my velocity final. So again, I know velocity final. I know my velocity initial. I know my acceleration. And I just need to use my time. So have, and we'll be able to find. And that is going to go into this equation. Then I'm going to add up all three of those numbers so that you have a reference point. I'm going to get 55.3 seconds is my total time stopped. Okay, let's go on to part B down here. Determine the amount of time the red light costs the driver compared to if the car has not been stopped by the red light. So we don't know how far away Milwaukee Avenue to the school entrance is. We don't have that information. So we're not going to be incorporating in the starting and the ending. I need to know what it is here. So if I'm going to take a guess, what do I know? It's going to be greater than 45 seconds. Why do I know that? Because the red light's going to be 45 seconds, and then there's going to be a small portion from the decelling and the accelerating. Okay. But I'm not just going to put 55.3. Why? Because at that time, they were still traveling to go through and find the answers. Okay, so you can't just say, oh, it's going to be 55.3 seconds. No, because we were still progressing. And for a teeny tiny bit of that, we were still at 22.5. So we have to go a little bit and a step further when we're doing this. Okay, so what do I need to know? What other information is out there that's going to help me? Okay. I need to find those times based on what? Based on my distances. Do I have a distance? No, because this line is just showing decelling and acelling, and it's basically a timeline. Okay, so what do I need? I need to know the distance that we were decelling, and I need to know the distance that we were accelerating, because then I can plug that back in and get the time comparisons, So the time, if we went 22.5 for the distance decel and distance acel, and then the other time for when we are actually slowing down and speeding up, so we can compare. All right, so what do we have here? What equations? Okay, so I'm going to need equations with what in it? Distance in it. So what are my equations that have distance? Distance equals velocity initial times time plus 1/2 AT squared. And my other one is velocity final squared equals velocity initial squared plus 2AD. So those are my two equations that have the distance in them. So I want to find distance. Do I know my initial and final velocities? I do know my initial and final velocities from looking at it here. So I have initial, I have final. Do I have my acceleration? Yep, I have my acceleration. Okay. And do I have my time? Do I have the time for decelling and the time for accelerating? Yeah, because that's what I put it in problem 1. But look at how much extra stuff I'm going to have to do possibly. I got to deal with a fraction, 1 squared, 1 non-squared, and I know one of these is going to be 0. So I'm going to go and I'm going to pick, but you could pick either one. There's not really a harder one here. I just know that in terms of calculator errors, I will have less calculator errors with this one. Okay, so for each one of those things, okay, for the decel, distance for the decel is going to use what acceleration? The negative 3.95. And what is the velocity initial of that guy? 22.5 squared. And what am I going to solve? And my velocity final is 0. So that speeds up that process for solving for D. So I can find that distance. What about my distance of accelerating? That's on that second side. Okay. Velocity final squared equals velocity initial squared plus 2AD. In this case, my velocity final is going to be 22.5 squared. My velocity initial is 0, remember, because we're accelerating, we're starting from a stop, plus 2, and this time my acceleration, 4.91. And that's going to give me my distance of acel. So I have my accelerating distance, and my decelerating distance. Okay, so what did I get here? That's number 4. Did I write it down? Oh, yes, I did write it down. Okay, 64 meters. Okay, but make sure you are physically putting your calculator so you don't mess it up on the test, even though I did show you your work here in these initial worksheets. Eventually, I will not be showing you the substitution. I will just be telling you what formula as we progress through. But I know sometimes it takes some time to get your math skills back. So I have those 2 distances. Now, what do I know? I know that the time is going to be equal to the let me write it the other way because I can't figure out. Velocity equals distance over time. So if I rewrite that, time equals distance over velocity. So I want to find the time that that distance would take at a velocity of 22.5. Okay. So I have the distance, 64 for the one, and 22.5, and I'd find the time here. And then I'm going to find my time for accelerating, and that is going to be my distance over here on the right over the velocity of 22.5, as if we did not stop. If we did not stop. So now I'm taking the time that way. So I'm going to have, it took me 55.3 seconds because of the light, and then I'm going to subtract off the time of decel and the time of acceleration, which these aren't really decel or accel, but that distance there for you to answer. The main thing, even though I use TD and TA, you are not substituting in these times for the bottom equation. You are substituting in what you got here. Okay, so if you wanted, you could call it something else like E and F. So that is number 3. Number 5. This guy is going to be a free fall because we're using drop towers. Okay, so we're dropping lead so that as it drops, it's going to fall and get a shape. Okay, and so we know we have a tower that's 63.9 is equal to the distance. We know it's going to be falling here. Okay. So my velocity initial is going to be 0 because we're dropping it. Okay. The velocity when it hits the ground is also 0, but most of these problems are going to be just short of hitting the ground. Okay. So determine how much time in seconds it takes for the shot to follow 6.39. So I look at my first formula, velocity final equals velocity initial plus AT. Velocity final. Okay, if I plug in zeros here, I'm not going to get a good answer for solving my problem because I'm going to have both of these terms knock out. So that's not going to give me an answer because I don't know what. I have no thing to compare it to. What is my statement? My distance. So I can't use some of the other formulas, even though you're like, oh, I could solve it. Yes, but it's not giving you a frame of reference. So you don't know if that was for a tower for 5 meters or a tower for 500 meters. If it's a 500-meter tower, is the time going to take longer? Yeah. So I need to make sure I'm incorporating the distance. So I check my distance formula. D equals VIT plus 1/2 AT squared. Okay. So on this one, do I know my initial velocity? Yep, that's 0. Do I know my time? Nope. Do I know my acceleration? Yep. And I tend to do 9.8 and keep it in the positive, and I just set it down as positive. Okay, but just go really carefully. That means this is 0 meters and 63.9 meters is at the bottom. So just really be careful with that. My distance traveled, 63.9. Could I solve it here? Yes, but I'd have to use the quadratic equation. Is there a better one? What's my other distance one? V final squared equals V initial squared plus 2AD. Know my distance, I know my acceleration, I know my velocity initial. Oh, I can't put 0 as my velocity final for the same reason why I couldn't use it up here. There is going to be a value there right before it hits that velocity that I would need. All right, and I don't have that information. So could I plug everything into this equation and find a velocity initial and then plug it into here to find the time? Absolutely. Or I could use the Pythagorean, I keep saying Pythagorean theorem, or I could use the quadratic equation for this one, whichever one you are comfortable with. And then look what it says. Determine how fast the lead shot is moving after free falling for 63.9 meters right before hitting the ground. That's this equation right here. So if I just do part B first, am I going to save myself some time? Absolutely. Right, 7. That's right off the notes. The area for velocity is going to be displacement. So just read carefully if they're talking about slope or area. Number 9. Okay, consider this graph. This is a velocity time graph. So the slope for this is going to be acceleration. Okay. And what do we know about the area? The area is going to be displacement. All right, determine the acceleration in meters per second squared. Okay, so my look, meters per second and seconds, so good. So I'm in the right units at 8 seconds. So 8 seconds is right here. A lot of people want to read that off the graph. What's that off the graph? Velocity. So you're not going to read it off the graph. What you actually need to do is find it from the slope of the line, and don't take it at the instant. Get in the habit right now of using just the slope equation. Change in y over the change in x over the whole line. It'll save you issues later on. 20 minus 4 for my y, and my x, 10 minus 4. And that's going to give me my acceleration. How about D? Determine the displacement. Displacement, that's area of the object for the entire 10-second interval. So we need an area. So we're going to break this down. It's not a function, so calculus isn't going to be as helpful. In fact, I would still be doing it this way even with calculus. So that's 10 times 4. That's the area of the square, base times height, plus this area of the triangle, 1/2 base times height. What's my base? 6. What's my height? Between 4 and 20, 16. Don't worry if they're different scales or anything else. Just plug that in there to get your displacement, and displacement will be in meters. There you go. That's all for today. Have a good day.